Using two-dimensional grids. We have already seen how to draw a grid or an array to show the sample space. But now, let's see if we can use a grid, also called an array, also called a two-dimensional grid, to calculate probabilities. It happens that a two-dimensional grid is a really useful way to calculate probabilities if there are two mutually independent events. By that I mean the two events have nothing to do with each other and don't affect each other at all. For example, if I flip a coin and then separately pick a random number from 1 to 4, if I get a heads on the coin, that doesn't change the chance of the number, right? It's completely different. So that means that they're mutually independent. The two events don't affect each other. First, let's draw the possibilities on a two-dimensional grid. In other words, we'll draw the sample space. There are two experiments here. The first experiment is flipping the coin, and the second experiment is picking a number. So let's do, on this axis, flipping the coin, and on this axis, picking the number. Now that I've got the experiment here, what are the outcomes for this experiment of flipping the coin? The two outcomes are heads and tails. And what are the outcomes for picking the number? There are 4 outcomes, 1, 2, 3, 4. Notice that I've put them in line with the grid marks, so then I can put a dot at each of these grid intersections. This possibility is getting a heads and a 3. This one is getting a tails and a 4. And I can answer questions like these. What is the chance of getting a head and a 3? The best way is to go through, well, probably the easiest way, go through the outcomes one by one and see if it matches this event, getting a head and a 3. This one here, is this a head and a 3? No, it's a head and a 4. This one, is this a head and a 3? No, it's a tails and a 4. This one, is this one a head and a 3? Yes, it is. And in fact, that is the only outcome out of these 8 that matches this event. Notice that I've got a green circle to mark this event, the outcome, or outcomes later, that match that event. You can use colours or symbols. It's a good way to show your thinking on the grid. So the probability of getting a head and a 3 is 1 out of 8. There's one outcome that matches out of 8 equally likely outcomes. What about the chance of getting a tail and an even number? Again, we can go through one by one. I'll write probability of tail and even. I'm going to mark the matching outcomes with a red square. This one here, is this a tail and even? No, it is not. It's a head and a 4. Is this a tail and even? Yeah, so it's a tail, 4. It's a tail and it's an even number, 4. Is this a tail and even? No. Is this a tail and even? No, this is a tail and an odd number. How many of these 8 outcomes are a tail and also even? There are 2. That one there is a tail and a 4, and that one is a tail and a 2. These are the 2 outcomes that match this event. So it's 2 out of 8 possibilities, which is 1 out of 4 when we simplify it. What about the chance of getting a head but not getting a 1? Probability of getting a head but not a 1. Here I've got a head and a 4. It is a head and it's not a 1. Tick and tick. So that one counts. This one doesn't count. It's not a head. This one is a head and a 3. That one counts. This one doesn't count because it's not a head. This one counts. It's a head and it's not a 1. Tick and tick. This one fails the head requirement. This one here matches the head requirement, but it needed to not be a 1, so this one doesn't count. So these 3 all match this event. So the probability of getting a head and not a 1 is there are 3 matching outcomes out of 8. And that is how you can use two-dimensional grids to calculate probabilities. And like I said before, they're especially useful if you have 2 mutually independent events. 2 events that don't affect each other, because you can put one event on the horizontal axis and one event on the vertical axis, list the outcomes here, list the outcomes here, and look at how many match. I hope this has been helpful, and I will see you all next time. Bye everyone.